So something which repeats. So we often find this, no? I mean, I want to do this repetitive summing up an array, you know. So we did that, in fact, in a loop in the last class. So there are two types of loop: for loop and while loop. So for loop is written like this: for elements in a list, body of the loop. So so we have elements in a list, okay, and so this body of the loop will be executed for all the elements of the list. So example is, so I have student list. So there are 4 students in this list, and I put a for loop for student in student list. So this is a list, and student is a variable I have created. Okay, so every student, this will be a student. This is student. Now, so what is body of the loop? Is print student and next line. So /n is the next line character. So print student and go to the next line. Now, so here I'm not saying for I equal to 1 to length of the list. So Python, in fact, is more powerful. You don't need to create a variable I, and you don't have to say from so this in C this variable would have to be an integer, but here it's not required. I mean, here it's a string. Okay, so we can also work with integer. I'm going to show you in the next example, but you can work with work like this. It's more powerful. Now so how does it work? So there's a student list. There's an index is created internally. You don't need to create the index. So it goes in and sees whether the student list is exhausted or not. I'm done with all the students. If yes, then get out of the loop. Otherwise, execute these two. So if I'm in the loop, student list is not exhausted. So print student list. That means printing that student name and increment the index. Okay. So I'm just trying to illustrate using a C logic. That's how a C program would have worked. Let's do this factorial. So factorial is just multiply, no? So factorial 5 is 1, 2, 3, 4, 5. But 1 I don't need to multiply. That's like wasting a loop. So I start with 2. So n equal to 5. So I declare a variable fact equal to 1. And for I, now I'm using that integer I, okay, because I need it here. I multiply. I in range 2 to n plus 1. Okay, why n plus 1? Well, range will create a list going from 2 to n. So it doesn't, the last element is not n plus 1, but last element is n, 1 less than the last n. Okay. So I just say fact equal to fact star. So this is body of the loop. It's just one line. And then I say print factorial. So print, you just please keep in mind that this is a string, then then a variable n, which is here, then another string, then comma, and fact, which is a variable. So how many elements are there in this inside the function? So arguments contain 4. One string, then comma, then a variable, comma, string, comma, and variable. And so yeah, I just said I ranges from 2 to n, and the answer is, so n is already known to it, so it just print. Well, sorry, I'm not running it in IPython. I made a file, so we can create a file with some editor, and we can run it. So I'm going to show you at the end of the class. So we can run it on IPython terminal. So run. So this is a Python file. Okay, so .py, and so it will give the answer. So it's printing. It runs this statements and prints. The last statement is just printing. So factorial 5 is 120. Now, so there's another loop called while loop. So it's slightly more involved. So a while expression. So this one is a conditional statement. If this condition is true, then you execute the body of the loop. If false, then get out of the loop. Okay. So we can implement factorial using the while loop. So so same as before, n is 5, fact is 1, I equal to 2. I just create a new line, I equal to 2, while I less than equal to n, which is 5, fact equal to fact star I equal to I plus 1. So I increment I. So I'm doing this increment by myself, which need not have been done. Like for loop is simpler, no? But anyway, to illustrate how while works, I is equal to 1. And so this loop is exactly the same, except, I mean, the same functionality. Here, this condition, as long as it's true, then you go inside. otherwise get out, and print the same. So if you run it, then you will find the same answer. So these are two loops which we have. We don't have repeat until in Python, which can be, I mean, you can write repeat until stuff using while. There's some more structures. So while is I just showed that this condition true, go inside, otherwise go out. Infinite loop. So you have to make sure that your program does not have infinite loop. So what is infinite loop? This loop will go on forever. Of course, you'll stop it after some time by some. I mean, you basically put Control C to stop a program. So I equal to 1, while I greater than 0, I equal to I plus 2, right? So what happens? I will go become 3 is greater than 0. I becomes 5 greater than 0. I becomes 7 greater than 0. So this will go on forever. Okay? So you should never have this kind of structure in your code. So this is of course trivial, but sometimes there's a real variable, and you normally would say that x equal to 3.0. Now Python is slightly intelligent, but let's say 3.14. You say I want to test whether x equal to 3.14. Do the loop. Otherwise, sorry, outside. If x equal to 3.4, get out. Otherwise, loop. But so real numbers testing may not be, equality may not work. So you may be going inside the loop forever. So you normally write x minus 3.14 less than equal to some epsilon. Okay. So put some. I mean, you don't want to compare two real numbers with the round off errors, and you will never get equality for real numbers. So be careful. I mean, it's not that this looks like it's a trivial example, but people do get into this kind of infinite loop. So this statement of break. I'm illustrating for this simple example. If I put a statement, if I greater than 100, then break. That means you get out. Okay. So this loop will, you can come out of the loop by break statement. You get out of the loop. So if some condition is true, then you just get out of the loop. Okay. So when will the loop get out? As soon as I becomes 101, the loop will get out. Okay. So it's one way to break. Of course, it's a trivial example. So let's do a slightly. In the next slide, I'm going to show you a slightly more complex example where break is useful. This for else is a nice structure in Python. It's special to Python, as far as I know. So else block is executed when loop finishes normally. There could be break statements. So if you get out of the loop by break, then else will not be executed. But if it executes finishes normally, then it will be executed. So yeah. So in fact, this example. Now I want to test whether a number is prime or not. Okay. So how do I test a number is prime or not? So I can just see whether I mean 2 divides the number, 3 divides the number, 5 divides the number. But how long do I need to go on seeing whether it divides or not? So you need to go up to square root of n. Okay. For example, if I take example like 49, so 49 is divisible by 7, which is square root. In fact, right now is. So we can take a slightly more complex example like 55. So 55, square root of 55 is 8, less than 8. No? So ceiling is 8. So 5 divides it. So you'll find that it always works. You go up to one of the factor has to be less than square root n, right? Equal to less than equal to square root of n, because other factor will be bigger. So I just go from 2 to square root of n plus 1, and of course I take int of square root n, because the square root n may give you a real number. In fact, it will give a real number often. So you create this integer and just go to ceiling. Now I test whether n percentage equal to I equal to 0. If so, that means n will divide, n is divisible by I, right? So this is a modulo operation. So print this, and hence n is not a prime, and I don't need to continue in the loop. I can just come out. As soon as I find one factor for the number, I get out. So I just declare that n is not a prime, and I get out. But if it continues up to square root n plus 1 and still does not find any factor, then it has to say that n is not a prime. So this loop, when it exits, finishes normally, then it will come here in else block and print n is not a prime. Okay. So this is a useful function for else. Okay. Otherwise, you need to do some more work. I mean, if this thing was not available, then when you get out, you have to know whether it got out by the break statement or it got out normally. and that if condition has to be here to declare that n is prime or not. Okay, so I'm basically done with the repetitive statement. Okay, so I just quickly want to show you how to edit a file. So you can use any editor you may like, but I use Sublime Text. Okay, so it's a free text editor, and a lot of people use this. Okay, so it's platform independent. You can get it from Windows, Linux, or Mac. So so I've typed code here. Okay, so x equal to 5, y is 10, and I do. So you can just type print, and here I put a tab, so I can. So for me, the tab is set to 4. Okay, 4 blanks. So I recommend that you can use uh, this editor, but you can use other editor as well. I mean, if you in Windows, there are just tons of editors. Linux too has VI and VIM, and so it's your choice. I use Sublime Text. Okay, now how do I run this file? So is there in this directory ch61? Okay, sorry, is in directory in the class. Now it's really da 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 da. It is. I mean, you can see the folder structure, no? So this is my home, Dropbox, courses, computer physics, books, the da 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 like that. Okay. Now, so if I go to my terminal, so let's first exit this. So this is my home directory. Okay, so this is a bit of Unix. This is my home directory. Then I can go to the particular directory by doing cd. So cd Dropbox. Then in Mac, it is this. The structure is visible. Well, I can set it to show me. Linux also has this stuff. Now we can keep going down courses. So yeah, I'm going to that no cd change directory, Dropbox, courses. Then so I put a tab. So if you set properly, then you put a tab, then it will auto complete. So, but you have to learn from Google how to do all this stuff. Okay, codes. So this is where I am now. I can say ls list. So the class. Now this is a directory where this file exists. Okay, so the file I showed you. Now I want to run this. So you remember I can go to do cd and go to that directory. Now it's a bit long, but I just too many files. I need to organize it. I can't put all of them in my desktop. It's impossible. But if you choose to put in desktop, you're fine. I mean, you're okay. Now I type this IPython minus -pylab. And now it has become a habit for me. I mean, even if I don't don't need this, but I still type. Then run that file cs6. So run is a function which will run a Python file, and will run it. Will create. It create output print. So you have a file you can execute within IPython. You can also run it by just typing Python. Once you are in that particular directory, you can just say Python. So you don't need to go into IPython and run it. You just do this, then it will also run. So Python, this command will just execute the file. Okay. So if you want to keep a file, no, I mean, if you have slightly complicated logic, you don't want to write again and again in IPython, you can save it and run it inside IPython. If your homework, you want to keep it safe in your directory, then you can save it. So in fact, you can recycle it. I mean, if you have good logic sitting here, good. I mean, you're like I have lots of codes, So for prime number, I don't want to write again and again. I have the code. I will just execute from here and run it. Okay. So you keep those codes for that is useful for your homework as well. Today's lab, we don't have complicated problems, but in your exam, you can use the code which you already have, no problem. But you can also use code from the internet, but you should understand the code. Don't simply copy. That is my strong advice. Don't copy blindly. We always borrow idea. I mean, we don't want everyone like a student or me to discover Newton's laws. Right? I mean, this we take from what is learned already and we just build on that.